Good morning.
Morning. How are you doing?
I'm all right. How about you?
Good, very good. Today we are beginning a new topic. So let me open that. Okay. Okay. All right. I'm taking attendance now. And sharing my screen. Okay. Let me see. The whiteboard. All right. I'm all set. So we are starting functions today. A new topic. We have finished with the loops. That was, a long section. I know that 4.5 was. And that part, section 4.5 is probably the hardest part of the course. Well, some students say functions are harder, but I don't think so. In my opinion, things are easier once you pass that topic. Anyway, let's understand what is a function. Okay, function is basically, here I have the explanation here. A function is a collection of statements written to achieve a subtask. So in other words, when you're writing a program to achieve certain tasks, sometimes within that task, within the larger task, there are some subtasks you can identify for which you can write a separate program. For example, in the last homework problem, which you just submitted, one of the problems asked you to get all the numbers from the user and then add up only the prime numbers entered. So you need to get all the numbers from the user, and each one should be checked to see whether it's a prime number or not. So what if I can write a subprogram, a separate program that I can use whenever I need to verify that something is a prime number? So that's what it is. You identify a subtask and write a separate program for that as a different program itself. Then we can go there whenever we need to and come back. So whenever we need to identify or verify that a number is a prime number, we can go to that subprogram and execute everything, bring back the conclusion, and proceed. So that is what function means, a sub program written for a subtask. So it would be written outside of the main. So within the main, you don't write anything about the sub program, the function. It used to be called subprogram, by the way. That's why I keep getting that name. Now it's called function. So anyway, we can always make a call to that outside function whenever we need to use it, and then we come back and proceed. That's how the functions work. So functions will be written as separate programs outside the main. It won't be in the inside the main. So whenever you need to execute the function, you write a statement which we call function call. You will learn how to write that. So that statement will make the system to deviate to the function. It'll go to the function and execute everything in the function, and then it will come back to the exact same location where it left off and proceed from there. That's how functions work. When the function call is executed, it'll go to the function, do everything there, come back to the same location. When you come back to the same location, you're bringing back the result of the function, and you're going to use that somehow when you proceed from there. That's how it works. Let's see how to write a function definition, how to write a function. Like I said, the function will be a separate program, so it'll have its own header. For the main program, the header is main. Main with the parentheses next to it, that's the header for the main program. For the function, there will be a similar header with the parentheses, and then curly bracket there will be a curly bracket at the beginning, and then all the C++ statements go there, and then close it with another closing curly bracket. We are going to first understand how to write functions, and then we will learn how to call the functions from main. So let's go to an example of simple function. Write a function to write two-line text on the screen. The two-line text would be this title, the Wonderland, and then underline it with the asterisk. That's all we want the function to do. So here's how we write it. Write text is the header. Right, basically the header will be the name. You make up a name for it. A name to identify that function. The name, when you make up the name should qualify to be a variable. See, all those rules we learned for variables, all those rules apply. See, I don't have a blank space, I have underscore instead. You can use underscore to connect two words, but you cannot use blank. Similarly, all other rules apply, all other rules for variables. So this is the name for the function. Next to the name, you need a parentheses. That's your header. This whole thing is your header. Then you need a bracket, and then cout \t, the Wonderland. That word, tab over, and then write the words, the Wonderland, ENDL, means go to next line. Then tab over and write the asterisk. So if you put tab, then we'll bring it to close to the middle. That's the idea. So that would put this on the screen. Wonderland and the underlining. So that's all this function does. It'll write those and close the bracket, and your function is done. So this function, whenever we call this function, it will write those words, the Wonderland, and it will underline that. So that's how you write a function. It's very simple. So where exactly do you place this in a complete program? We can place it at the top of the program, like in the same file where you type your main. You can type this above main or below main. If you choose to type it below main program, then you need to put something at the top indicating that there's a function at the bottom. We'll do all that, we'll learn all that later. But normally we will put that at the top. So this write text goes to the top and then begin the main. So right after this, curly bracket, right after this, this is where you will begin your main if you're writing a complete program. Main goes here and then proceed. And then within the main, whenever you need to call this function, you can make a call. Then it'll come here and do everything here and it'll go back to the same place and so on. That's how it works. Okay, so that's a simple function we wrote as an example. Now, before we write more functions, we need to understand the return type. The functions are usually written to return some answer to the main program. So there will be a statement inside the function that will say return this. So normally, I mean, sometimes you don't return anything. Like in this case, this example we just wrote, this function is not finding an answer and returning it to the main. That's why I don't have a return statement anywhere here. Because it's only doing the job of writing the text and writing and underlining, nothing else. And there's nothing it's going to calculate and pass back to the main. So that's why there's no return statement. But almost always your function will be returning something. So the type of value it returns, you need to identify that. You need to identify what type of value our function is returning. And that is your type of the function. So there is a data type for the function. The data type of the function is the data type of the value it returns. So that's what we call return type. You need to identify and you need to tell the system what type of function it is based on the value it will be returning, like int, float, char. It can be even double. So any of those data types would come in, would become your data type of the function. So the point is the data type of the function is the data type of the value it will be returning. And if the function doesn't return any value, the data type of the function is called void, V-O-I-D, void. So you need to identify the data type and put that in front of it at the header. If the function is finding maximum, then I can call it find max. And if it is working with float type values, then the maximum will be a float type value and it will be returning float. So I need to put that in front of it. The data type has to go in front of it. Function write text we wrote earlier, that doesn't return anything. So the data type is void. You need to put that in front of it. So always a data type must go in front of the name in the header. The header of the function would have both of these, the name for the function, the data type, and then a parentheses. The parentheses is empty in the case of main, right? Main has the parentheses too, but main has it empty. But in the case of functions, the parentheses are not always empty. Sometimes they are not. And we will learn all those details as we proceed. Okay, so let's understand the parameters of the function. Now, I just said the parentheses that we write next to the name of the function in the header of the function would not be necessarily empty. Sometimes we need names there. So let's understand when we need variable names. Functions sometimes need to receive something to do their job. The function we wrote earlier, this function that writes title, function write text, that doesn't have to receive anything. Its job is to just write something, so it doesn't need anything to do the job. Other functions need something to do the job, like function find max. Function find max is going to find maximum of two numbers. It will determine which is larger. It will receive two numbers and determine which is larger. Just to make it a simple example. I mean, there are more, much better examples coming up later. But to understand the concept, we'll write a function called find max that will receive two numbers and it will return the larger one of those. So we call it find max. So to do the job, it has to receive two numbers, right? So those two numbers will be received inside the parameter, inside the parentheses like this. You need to list two variables. Each one should be declared separately. So that's what these are. Float num1, float num2. This means this function find max, whenever this function is called, two numbers will be sent over. Those two numbers will be received in these names. The first number will be num1. The second number will be received in num2. So this function will work with only num1 and num2. It doesn't know what variables are there in the main program that have the numbers. The numbers are going to be passed into these variables. So function find max will only work with these two variables and find the larger one of these. So, well, we're going to write these as our examples. Let's proceed to understand the return type. Then after we understand the return type, we'll be ready to write our function. We just learned return type. Whatever the type of value it returns, that's your return type. So here's the body of the function. Here's how you write the function. You write the return type and then a name for the function. Usually the name should correspond to what the function will do, make sure the function name makes sense. Then you need the parameters. Inside the parentheses, each parameter will be declared, the data type. You can have any number of parameters. If you have 5 parameters in the function header, that means it will receive 5 numbers. It must receive 5 numbers to do the job. Otherwise, the function call will not work. So inside the function, you do not declare these parameters. They're already declared. See, right here, the parameter is declared. You only declare any additional variable you need to use that are within the function. No variable in the main program will be recognized here. So any variable you declare here will also be local to this function. They will not be recognized by the main. The main and the function have no way of knowing each other, no way of knowing what is inside. The only way of communication would be parameters. The parameters that are here in the parentheses, numbers will be received in these parameters. And that's the only way of communication. So you write all these declarations of local variables that are needed within the function, and do all the work using C++ statements. And normally you will have a return function at the bottom. A return statement will say what to return. So if I have a variable X holding a value that I need to return, this is my answer. The answer is in the variable X. I can say return X. That means return the value of the X to the main function. So when you go back, that value will be returned to the main. Now, we'll be seeing exactly how the main program will communicate with the function in the next section. So we are going to basically focus on how to write the function in this topic, in this 5.1. So 5.1 is about writing the function. So let's go to an example. Function find max is going to receive 2 numbers, and it will find the maximum of the 2 numbers. I'm writing it in one way. This is not the only way you can write it. There are many different ways to write it. But I'm writing it this way to illustrate a normal function that you commonly have to write. So function find max is float type. Return type is float because it's receiving float type values, two numbers. Num1 is float, num2 is float. So obviously the maximum will be float number. So therefore return type is float. Inside, I'm making a local variable. You can do this without making up a local variable. But just to illustrate all the things you normally do, I have a local variable. This variable is only recognized here within the function. Outside, if you go to the main and refer to maxnum there, it doesn't know what maxnum is. There is no maxnum in the main. It's a local variable. So then I say if num1 is greater than num2, then copy num1 into maxnum because num1 is the larger one. Otherwise, copy num2 into maxnum, return maxnum. Return whatever the value maxnum has. That's your function. Function will find the larger of the two numbers and it will return it to the main. How does the main handle the returned value? We'll take that up in the next section.
I have a question.
Sure.
I thought you said that for you to work with variables, it would need to be like up top where float num1 and float num2 are. But don't you have max num there? Wouldn't you need to put max num also in the parentheses?
No, you don't. What you write in the parentheses are variables in which values will be received. Only those will go into the parentheses. The values
Oh, values that are received from the other
that are
function
received
from main.
from the main, yes.
Okay.
So
Oh,
whenever the main calls this function, it has to pass two numbers. The first number, it has to pass two numbers in parentheses. The first number will be copied into num1, second number will be copied into num2, and then it'll proceed to do all this work. Understand?
okay.
So
Yeah.
any variable you need within the function would be declared here, not in the parentheses. Okay? The parentheses, these are called parameters. Parameters are only for receiving values from the main. Okay?
Okay.
Got it?
Now, I also have another question about max num. It says return max num.
Yeah.
If I'm not mistaken, you said that whatever is in the function, I think you said doesn't affect the main, right? So when you press return max num, what does that exactly do?
That will take the value the maxnum has back to the main. Whatever the value maxnum has, it'll go back to the main program as the result of calling this function.
Okay, thank you.
So the maximum finds the answer that the main program needs to find, and it returns the answer. And so the answer is stored in this variable. So I'm saying return the value stored in this variable to the main. Okay. All right. So how does the main handle that? We'll talk about that in the next section. So right now we are focused on the function. Any other question? Feel free to ask the question. If you understand function, it's very easy. But if you try to work with it without understanding, it is very difficult. So feel free to interrupt me if you have a question. Going on to the next one. Now, the functions have this nice feature of returning, right? So returning, does it have to be done at the bottom as a return maximum like I did here? No, not necessarily. Whenever you find the answer, you can return. At that point, you don't have to proceed to do anything else in the function. If you find the answer at some point within the function, it doesn't have, basically I'm saying your return statement doesn't have to be at the bottom of the function. Whenever the answer is done, answer is ready, you can say return this and don't worry about the rest of the function. Ignore the rest of the function. You can say that. So that's what I'm illustrating in the other one, in this example. Your program, your function is going to find the square of a number received. So it'll receive a number in this variable now. When the main program calls this function, it'll send one number. That number will be received in this variable num. And then we need to find the square and return it. I can write directly without using local variable. I can say multiply num by num and return that. So you don't have to have a local variable to store the answer and everything. Just the return statement can be written anywhere to return the answer when the answer is ready. So that's an example of another function.
I have a quick question.
Sure.
So you could type return num times num instead of answer equals num times num? Okay.
This can be written that way. It can be written with the variable if you like, but it's not necessary. Like this, if you write it this way, you have to declare your local variable. So int ans equal to num times num, semicolon, and then return ans. That'll be correct way too. Okay, nothing wrong with that. But you don't have to write these two lines. Instead, you can say return num times num. Let's proceed to the function write text. Now we are rated write complete function. Function write text is void because it doesn't return anything. And it has empty parentheses because it doesn't have to receive anything to do the job. The job is to write these texts on the screen. So there's nothing to receive, nothing to return. It'll just do this job. So if the function is not going to receive anything, you can leave the parentheses empty. And if it is going to receive something, you need a variable to receive. And the variable type has to match the data type of the data that you're going to receive. Okay, so let me see if you can write these. You need to start writing function to understand the rest. So I need to see you write this. When you finish one of them, I want to see the answer. All right, I see Emmanuel showing me. Can you put it closer, a little bit closer, please? No. Right, you got it. You got it. Emmanuel got it. Very good. Oh, not Emmanuel. That was, sorry. Why isn't your name showing up? Not showing up here. Anyway.
Oh, I'm not sure.
Yeah, your name is not showing. Okay, so anyway, one student got it right. Very good. Others? That's clear, right? Clear. I remembered. Anybody else? But clear, work on the second one. Okay. All right. Everybody knows how to get the last digit of any integer. If you don't, ask me.
Yeah, I'm not too sure on how to get the last digit.
For any integer, if you take modulus 10, it'll return, the modulus 10 will be remainder. So the remainder of dividing any number by 10 will be same as last digit. If you divide 253 by 10, 3 will be the remainder. Okay, So you just need to use modulus operator with 10. We did all this in chapter 2 or somewhere. Chapter 2, I believe. You got it, David?
Yeah, thank you. Thank you.
You need to turn your video on if you're going to show me an answer. I'm still waiting for the answer for the first function. I have only seen one of them. Okay, I see another solution. A little bit closer. All right, there we go. I see now. Return. Yeah, that's right. But the number received will not be float. It's int. Okay. Int. All the numbers are int type here because and the problem says that clearly, right? So integer. Yeah. Other than that, you got it. So I have seen 2 students, 2 answers. Or I see a third one. Digit return. Right. Very good. Semicolon missing. Other than that, it's right. Very good. Okay, now I see second problem. Cleo is showing me second problem. 2 times r times h plus r. Right, very good. Yeah, Cleo got it. Got the second one right. Okay, Miss Angdembe, I think you're ready to show me a solution. All right. A little bit up, move up a little bit. Up, okay, got it. That's, looks like that's the second one. All right, now, okay, first one. Move it closer to the camera. All right, now I see. Right, okay, very good. Let me see the second one. I think you have the second one. What did you do with the pi? Oh, you put the number there. Okay, right, very good. Okay, you got it. All right, so 2 students showed me both solutions. 1 student showed me the first one. All right, I'm going to, I'm sure some of the others got it, but I cannot wait anymore. I'm going to show you how to write them and then proceed. So the first function is called digit, and it's going to receive an integer and it will return the last digit. So since it's receiving integer and returning 1 digit, it's integer also. So return type is int. So int, I'm writing the solution for the first one, exercise 1. Int digit is the name for the function. In parentheses, I need to receive a value. So I make up a name for it. I make up any name. Num is fine, num. Now this name is for receiving a value. It's going to receive only one value, so I only need one variable there. And inside the function, I need to do the work. Well, all I need to do is find the last digit. So num modulus 10 will be the last digit. So I can say return that, semicolon, and done. That's it. Return, that'll return the last digit of the number received. Exercise 2, this function has to receive two numbers. One is the R, the radius, and the other one is height. So I can make up two names for them, but these are going to be float type. So the surface area that it finds is also going to be float type. So float surface is the name. And I had to receive two float numbers. So float, I can make up names here. The name I make up here is only going to be known within the function. So I'm going to use h for the height and r for the radius. So float r, comma, float h, two things to receive. So the main program will have to pass radius into the first variable, height into the second. So this will find the volume. So I can make up a local variable volume if I needed to. I'm going to do that just to show you how to do that. Float vol equal to, so this is a local variable, 2 times pi. You can make a constant pi, that will be a better way, but I'm going to put the number directly, 3.1416 times r times parentheses h plus r, semicolon. That's a volume. And then you can say return vol and close. That's your program. That's your function for finding surface. All right, so moving on. I'm going to write another function. Here I'm going to illustrate a return statement using more than once. You can use return statement, in more places than once in your program. And this example illustrates that. Write a function that receives a character. This function is going to receive a character, and it will return a 1 if the character is lowercase alphabet, and it will return 0 otherwise. So it's checking basically to see if the character received is a lowercase alphabet or not. So that all our concern is, if it is lowercase alphabet, then we'll return a 1. Otherwise, we'll return 0. Okay, so the name of the function is lower alpha. It's returning 1 or 0. So return type is int, and you'll receive a char type value. I made up a variable named val to receive it. And then if val is bigger than 97 and less than 122, then it is lowercase alphabet. In that case, return 1, else return 0. So all we are checking is whether it's lowercase alphabet or not. If it is not lowercase alphabet, we are returning 0. Okay, so at this point, let me explain something. Can I return true or false instead? Yes, I should have brought that up in this presentation, but let me rewrite that particular function as a function that will return true or false. Okay, so if I want to return true or false, so the name of the function is lower alpha, and I still receive a character value, so it's char val, and I'm going to return true or false. If it is lowercase alphabet, I'll return true. Otherwise, I'll return false. Okay. So I'm going to return a true or a false. So that's Boolean value. The data type of the return is Boolean value. So bool is the data type of the function now. Bool, and then inside, if these conditions are true, then I'll return true. Remember, the word true is Boolean value. Else, return false. That is very much correct. You know, it's same as this, except the Boolean value is being returned. Okay, so let's move on. The return, so you have seen a return 0 written in the main function at the bottom usually. The reason is the function, main function is also a function. That's why you have a parentheses next to it to indicate that it's a function. But the main function doesn't return anything to any other function. So therefore, you write a return 0 to mean that you're not returning anything. Well, in the initial versions of the language, that was required for every function. Every function must have a return statement. You know, that was the rule in the earlier version of the language, but then later it was eliminated. So it is not required that you have a return statement in the main. So the return 0 in the main that you see in some versions of programs is not really necessary. You don't have to write that. But you understand the reason for it. The functions are normally written to return something, and the main is also written as a function. So therefore, there must be a return statement returning basically nothing. And that's what that was for. But it's no longer required, so you don't need to write that. All right, going on to another warm-up exercise. This one says, write a function called toUpper that receives an alphabet unknown as to whether it's lowercase or uppercase and converts it to uppercase. So if it is, so here's what you have to do. You receive a letter, and then you need to check to see if it is lowercase or uppercase. If it is lowercase, you convert it to uppercase and return. If it is already uppercase, you just return the same. Okay, so if it is already uppercase, you return the same. You do nothing else. If it is lowercase, we return uppercase version of it. But you can assume that it's an alphabet. Okay, you're not receiving anything else, some other character. You can assume you're receiving alphabet and return it as is if it is already uppercase. Otherwise, convert it to uppercase and return. So let me see if you can write it. If you're using numbers, the numeric equivalents, then 65 to 90 are the uppercase ones, 97 to 122 lowercase, 65 to 90 uppercase, 97 to 122, lowercase, if you want to use numbers. You could use characters directly, but if you want to use numbers, those are the numbers. 65 to 97, sorry, 65 to 90, and then 97 to 122. Uh,
Professor, I think I got the answer.
okay, let me see. Okay, and char val equal to val minus 32, return val. Right. Val, but the val is the val is char. And you're changing. Right, you got it. Yeah, you can use that parameter. He's using parameter itself to store the result, which is okay. No harm done. Okay, so if you're wondering, if the others, if you're wondering how to convert, I think you did that in one of your homework, but if you're wondering how to convert, you just have to, the difference between lowercase alphabet and uppercase alphabet is 32. Every alphabet, lowercase and uppercase, differ by 32. That's what you need to use. Okay, I see solution here. 6590, return that. Otherwise, return. Right, very good. Very good. Joseph Tran just gave me an answer, which is good. Right. Yeah, I just saw you. You got it. You got it. All right, so that's 2 students so far. A whole bunch of students have the video turned off, and so I don't know how to help them. Okay, I see another 2 solutions. So hold on. Return minus 32, otherwise return. Okay, yeah, Cleo got it. Yeah, Jennifer, can you show that again? All right. Yeah, Cleo got it. I'm waiting for Jennifer. Oh. Anybody else? Okay. All right, I'm going to show you. I'm glad to see that several students got it. That's good. I'm going to show you how to write that function. The function is going to return a alphabet, basically converted to uppercase. So therefore, I need the return type is character. So char type, to upper is the name, and it's going to receive a character. So char al to mean alphabet. And then there are several ways to, I mean, there is no unique way to write the whole thing. You know, there are each student who showed me a solution had a different version. They're all right. They were all right. So I'm going to write one version. If the character is already uppercase, then I don't need to do anything. Only if it is lowercase, I need to change it. So therefore, if it is lowercase, how do I check for lowercase? If val is, not val, al is greater than 97, and you need the and operator, and al is less than, greater than or equal to, by the way, or and less than or equal to 122. Only if it is in that range, 97 to 122, then it is lowercase alphabet. Then how do I convert it to uppercase? Just subtract 32. 97 minus 32 is 65. 98 minus 32 is 66. So any alphabet that is uppercase can be converted to lowercase simply by subtracting 32 and then converting it to character. You have to make sure the answer will be character. But the al here is already declared as character. And therefore, if I do al minus 32, since al is already a character, if I put it back in al, then I have converted to lowercase alphabet. And now if, so see, I don't have to, see when you do this al minus 32, al is character type, 32 is integer type. So it'll convert both of them to integer, remember, to larger type. And so the result of this will be integer. But I'm assigning it to al, which is character. So I'm converting it to character by doing that. So al has a character which is lowercase. So if it is uppercase, I don't need to do anything. So therefore, I can simply go out of the if statement and say, return al. If it is already uppercase, I'm returning the same thing back. If it was lowercase, I have converted to uppercase in this statement right here. I've converted to uppercase. So that's all I need to do. Close it and we're done. We don't even need to check to see if it is uppercase or not. There's no need for it. If it is uppercase, just return it as is. All right, moving on now. Going to bool type. Now, you already know bool type, but I need to remind you that if you evaluate any inequality, such as x greater than y, the value will be a Boolean value. It will be true or false. If you want to convert it to integer, you can do that by assigning it to integer variable. And if you convert true to Boolean, the Boolean value true to integer will be 1. The Boolean value Boolean value false will convert to 0 if you convert to integer. Only if you convert to integer. Otherwise, they will remain as true and false. To declare a variable to hold a Boolean type value, the keyword is bool. These were all done earlier. I'm just recalling it. So here is an example of Boolean. Just to recall your understanding. Int x equal to 15, y equal to 3, bool is div divisible or not? That's our question. Whether 15 is divisible by 3 or not, the result of that is going to be stored in this variable. That will be a Boolean value. So x modulus y equal to 0. This expression will be a true if 15 is divisible by 3. It'll be a false if it is not divisible. That true or false is being stored in isDiv. We are not converting. We are storing the true or false in isdiff. So isdiff has the true or false. In this case, it will be true because 15 is divisible by 3. Anyway, that's just to recall the Boolean types. So here's an example of Boolean type. We already did one, but let's do another. This function will determine whether first number is divisible by the second number received. It'll receive two numbers and it will determine whether first number is divisible by the second or not. And so it's going to return a true or false. So return type is bool. The name of the function is divisible. And two numbers are received in x and y. They're both integers. So all I need to do is determine whether x modulus y is a 0 or not. If x modulus y is a 0, then I need to return a true. So here's another way a student would tend to write. It's not wrong, but I want to write that version and show you. Bool divisible. And inside int x, int y. And then if x modulus y equal to 0, then that means x is divisible by y. In that case, return true, else return false. This is naturally the way students would tend to write, and it's not wrong. This is right. But as you can see, the way I'm writing simplifies matters. I'm just saying if x modulus y equal to 0 is true, then return true, the same value. If it is false, return false. That is the same as this. That is same as the version I wrote on the board. I'm returning true if x is divisible by y, and returning false otherwise. So the version I wrote on the board is a slightly longer version, and the version on the presentation here is much shorter. So whatever the x modulus y equal to 0 evaluates to, I'm returning that because that is our conclusion. Okay, another warm-up exercise. So let me see if you can write just one. Let me see. Find the smallest positive integer that divides both evenly. Yeah, maybe the second one, 5.1.5. It'll find the smallest positive integer that divides both numbers evenly. The function is called common divisor. It'll receive two integers and it'll find the smallest number that divides both. Smallest number that divides both. Let me give you a hint. If you want to find the smallest divisor, you start at 2 and check every number, 2, 3, 4, 5, to see which one divides both. You're finding number that will divide both. And if you start at 2, you're starting at the smallest possible divisor, 2, and then move up. So if it doesn't divide, move up. When you find the divisor of both, you're done, you return it. So if you start at 2 and go up, then the first divisor you find for both is going to be the smallest. For those students who are not doing anything, it's not a good idea to do that. You know, you have to participate to be able to learn. You need to try and then get help from me if necessary. Or if you want a hint, I can give you if you ask for one.
Because I think I got it.
Okay. All right. A little bit closer. Let me switch. Hold on. All right. That's better. All right. I can see now. Number 2. You're only checking one number, 2. You're not checking all the possible devices. You're going to need a loop. Okay, you have the right idea, but you need a loop to check all the numbers starting at 2. You need to check the 2 to see if it is a common divisor, and then 3, and then 4. You have to keep going until you find one. When you find one, you can return it. And you have to allow the possibility that you don't find one. Okay, I see something from Cleo. Okay, finding minimum. Right, very good. Yeah, Cleo got it. There are just some fine details you can improve, but other than that, it's correct. So one student has the right program. Remember, this course is about programming. You know, you have to be able to write program at this point. Otherwise, you haven't learned it. All right, I'm going to just explain. One student got it, but I'm sure others have written some of it, but I will go over it, and we have to move on. So I have this on the board. I have int comdiv parentheses int m int n, because it will receive two numbers in the variables m and n, and then we have to find the smallest divisor. Um, the smallest divisor is going to be something less than or equal to m and n, right? Something smaller. But sometimes it is possible that m divides n. If m divides n, then m is the smallest divisor of both, right? We can allow those possibilities. It's not asking for proper divisors, so it could be m dividing both, then m is the answer. So we should allow all those possibilities. So therefore, my loop, I need a loop to test all the numbers. So I'll write it as a for loop for test going from 2, test equal to 2, semicolon, test number is the number that I'm testing for divisor. That will start at 2. And it'll go up to m or n, whichever is smaller. So you can either find the smaller one first and then go up to that, which is what Leo did. But I'm going to just I'm going to say test must be less than or equal to m, and test must be less than or equal to n. It must be less than or equal to both. So that'll be another way. As long as it's less than or equal to both, and then test will increase by 1 each time. For all those numbers, all those test numbers, if I need to see if that test number is a divisor of both m and n. So if m modulus and m modulus test equal to 0, and it has to divide both. So m modulus n modulus test must be also equal to 0. If both of those are true, then that's the number. That is our answer. So return test. If the test number divides both, then return it. That's the end of it. We don't have to continue and finish the whole testing. Anytime one number divides both, it'll return. And notice that I'm allowing test number going equal to m and equal to n. So if m is smaller and when test number equal to m, then if m divides both, that's included, that's covered here. If the test number is equal to m, then m modulus test will be 0. M, it divides itself. And if this is also true, then I'm returning the m. The m can be my answer, or n can be my answer. I'm allowing test number going up to m or n, whichever is smaller. So this will return any number, the smallest number that divides both. And if that smaller number happens to be the number itself, like this, let's say the n is 27 and m is 9, then the common divisor is 9 itself. And if that's the case, my program works even in that case, because m is 9. When the test becomes equal to 9, it does find that this is true, so it will return the 9. So you should allow all those possibilities, and this does. So only if it goes all the way to the larger number and doesn't find any of them dividing both, then it'll come down to this line. If it finds the common divisor, it'll return that number there. Only if it doesn't find anything, I need to return something to indicate that there is no common divisor. So I need to return some number to indicate that there is no common divisor. So I can return a -1. And so the main program has to recognize that if the number received back is a -1, that means no common divisor was found. So you need something to indicate no common divisor was found. Could be 0, you can return 0, but -1 is a better way. So that's all there
I have a
is.
question.
Sure.
So is -1 the universal way of saying like there's nothing that
No,
divides
you can build, all anytime you write a program, you have to make this kind of determination. So when the program is when the main program sends a number, sends two numbers to this function, to any function, you should allow the possibility that the function doesn't find an answer, doesn't find a number that, that is correct answer for the problem. So you just build a mechanism to send a message that there is no such answer. So it's not necessarily -1. It can be 0 or something that is, you don't want to return a number like 5. That would mean 5 is a divisor of both, right? So you should return something other than a normal divisor, a normal number that qualifies to be an answer. So something else like -1. We are not testing -1 to be a divisor. So if you send something that is not a divisor, that is a signal that it is not found. No such divisor was found. So that's why I'm sending -1. So you can just use something that is not a divisor of both numbers. Okay, so you don't
So
want to.
you can use 0 if you wanted to.
You can use 0. Yes.
Okay.
All right.
I have a question.
Yeah.
You see how you started with 2? What if 2 was the answer? Because you already test plus plus it. So wouldn't you start it off at 1?
No, no. You're forgetting something in the for loop. Whatever you start with, this is starting value that will be used. So when the test is 2, with the test equal to 2, the program will check this condition, and it is true, right? 2 is less than or equal to both 9 and 27. Let's use 9 and 27. It is less than or equal to both. So it will test the 2. I am testing the 2 here. Understand? I'm testing the 2. And only if that is not a divisor, then the return test will not be executed. In that case, the loop will go on to incrementing test to 3. This test plus plus will be executed only after executing the body of the loop. Understand?
Okay.
All right.
Yeah, I understand.
So it'll increase to 3 only after testing 2. So I am testing 2, 3, 4, all of those numbers, all the way to 9, including 9. Okay, any other question? Feel free to ask. All right, moving on. So now we have a program that will return the count of devices of a number received. You're going to have homework problems like these, okay? So you need to understand how to write these functions. This function will receive a number, integer number, and it'll determine how many devices are there and return that count. All right, so I need test number to test for divisor. Count is going to count the devices, initially 0, and test number goes up to num over 2, while test number is under num over 2, less than or equal to num over 2, because only a number up to half of the given number can be divisor. For any number, an integer larger than half of that number cannot divide it evenly. So that's why I'm going up to half of the number. For all those test numbers, if num modulus test is equal to 0, then increment the counter. Whether that test number divides it evenly or not, either way, test number should go up. That's why test plus plus is at the bottom. Test plus plus is outside the if, because if test number is a divisor, increment the counter, but whether it's a divisor or not, we should go to the next test number before going to the top of the loop. So a new test number is tested and then checked to see if it is a divisor. If it is divisor, counter goes up, otherwise counter doesn't go up, but the test number goes up to the next. And I keep going, and the loop will continue to count all the devices. When the loop finishes, it'll come to this line, this line. There I say return count. The count is our answer. So return type is a integer because I'm returning the count, and that's why return type is int. Okay, so warm-up exercise again. This is I remember in the last question in the last assignment was to receive all the numbers from the user. You know, you read numbers one at a time from the user, and then you need to add up the prime numbers entered. So if you can write a function that would determine whether a number is a prime or not, then it'll be easier to write that program. You can call the function to determine whether a number is prime or not. So that's what this is. Write a function called isPrime that receives an integer and determines whether or not it's a prime, and writes and returns a conclusion. So the conclusion can be will be true or false. It makes sense to return true or false. If it is prime, you return true, otherwise return false. So whenever you write this function program to determine whether a number is a prime or not, you should write it the most efficient way, which is the most efficient program we learned. There were two versions we learned, and one is supposed to be more efficient than the other, and you should use the one that is most efficient, okay? But if it is a test question, actually I had this question in the last test, but some students did it correctly and some didn't, and one student did it the other way, which is the inefficient way. I gave him partial credit. So only if you write the efficient program, you get the full credit, otherwise you get partial credit. So if you know some other way of doing it, do it. You know, write the program in whichever way you know how to write. You will get partial credit. I'm going to go over this myself because we don't have much time. So I'm clearing the page, and I'm writing the function isPrime. IsPrime will determine whether the number received is a prime or not. Okay, so return type is bool because it's going to return true or false. Let me change my pen. Okay, so bool type isPrime is the name. It'll receive an integer number n. And then inside, I'm going to declare a bool type variable to store the result. So true or false is our question. Bool, I'm going to call it prime, equal to, begin with true. So I'm beginning the variable with the value true, and then which means I'm assuming that the number received is a prime to begin with. So prime will remain true. To the value of prime is true means the number integer n is a prime. Starting with that assumption. And the next thing I'm going to do is int test. I need to start my test numbers going from 2 to 4, test going from 2 to test less than or equal to less than n, because we want to see if there's a proper divisor. So I had to go less than n now. Test plus plus. For all these test numbers, I need to see if I found a divisor. So if test number divides the prime, divides the n, if n modulus test is equal to 0, that means we found a divisor, then the number is no longer prime. So I started with the prime being true. So if test divides n, then the prime is going to change to false. Prime equal to false. So this will repeatedly test 2, 3, 4, all the way to n. And if any one of them divided it, then the prime would have changed to false, which means that n is not prime. So if I find any divisor, the conclusion is it's not prime, so prime changes to false. So if the loop goes all the way through and it never finds the divisor, then the prime will never change to false. It will stay at true. So the prime has the answer as to whether n is a prime or not. I started out assuming n is prime and then tested all the numbers under n to see if anything divides it. If anything divides it, then the prime changes to false. And so when this loop ends, if the prime still has the value true, that means the number is prime. If the prime changed to false, then the number is not prime. So what do I return? Anybody? I already have the answer. It's stored somewhere.
You return prime?
Prime, yes. Prime has the answer. The prime remains with the value true if the number n is prime. If the n is not prime, prime has already changed to false. So prime has the answer, so return prime. And so that's it. So as you can see, when you write it as a function, you can, the program sometimes is shorter because there's a slightly different way of doing it. Let me also explain a quick change from this function. Instead of this, I could have done this. Instead of using prime as a value, as a variable to hold the answer, I could have said this. I could have avoided the prime altogether. And then in test, and I'm not testing everything, if anytime divisor is found, I know it's not prime. So right there, I can say, instead of doing all that, I can say return false. In other words, if I find any number, any test number starting from 2 to n, any one of them divided, immediately I'm returning a false to the main. And then if no divisor was found, this return false would never be executed. Only in that case, it will come down outside the loop. If it comes outside the loop, now I can say return true. I don't have the variable prime anymore. I can just say return false and return true. That's another way. But using the prime is a neater way. For a reader, it's a lot better to understand. But this is also correct. Basically, I'm testing all the numbers. If any test number divides it, I'm returning false immediately. And if no number divides it, then this return false will never be executed. And that's the only time it'll come down to the statement outside the loop. There, I say return true, because if it comes here, that means it never found a divisor. So there I can say return true, and then I'm done. So that is also correct program. So the correct program can be written in many ways. And when you're writing it as a function, often it becomes shorter because of the return statement. You can return whenever you find the answer. All right, so we are going to close here. And 5.1 is finished. So you do all the exercises indicated in your course calendar for the homework, and that's due Monday. And I have office hours this afternoon. So if you go and get started with the 5.1, then you'll have a chance to ask questions if you have any. And if you need help with the project also, this office hours is the only chance to ask for help. This project, by the way, is probably the hardest one. So, you may need help, and feel free to ask for help if you need. All right, enjoy the rest of the day and enjoy the weekend. I will see you Monday.
Have a good weekend.
You too. Everybody have a good weekend. I'll see you Monday.